In this section, we're now going to look at something called inferential statistics. We're going to trying to figure out what we have and what we need to get what we're looking for. What is probability? We've been talking about statistics so far, but what is probability? Statistics is an analysis of the past. Probability is an analysis of a guess of what may happen in the future. That's what they call gambling, a exercise in probability. You have a chance of winning, you have a chance of losing. So that's what we're looking at here. Looking at example 1. Analyzing a claim. Here's the claim. We have developed a gender selection method that greatly increases the likelihood of a baby being a girl. That's the claim. The hypothesis, in order to test this claim, because once you make a claim, you have to test the claim to see if it's true or false. That's the hypothesis. The method of gender selection has no effect, so that for couples using this method, about 50% of the births will result in girls. What does that mean? What is the probability of a birth being a girl? 50-50. You really have no choice in selecting this. You can try to guesstimate what it's going to be, but again, it's 50-50. That's what we're looking at. So let's look at this. Whenever we're talking about births of, these are called binary events, where binary events are events that only one of two possibilities comes out. When you open the door, is the light going to be on or off? That's only two possibilities. It's either going to be yes or no. Is the baby going to be a boy or a girl? 50-50. So when they talk about gender, but it's more than just gender. It's anything that deals with anything binary. On, off, boy, girl, good, bad, red, white, tall, skinny, tall, short, fat, skinny. So here we're going to look at 20 births. Test A, test B. So if we have 20 births and all of them come out to be girls, how many boys are going to be? 0. If we have 12 girls, that means we'll have 8 boys. We can calculate these probabilities. The probability of getting 20 girls in 20 births is given by this chance. It's the probability equals 954 divided by 1 trillion. And this one, the probability of 12 or more girls is equal to 251,722 in every 1 million births. So that's 0.251722. This one is 0.00000000954. So which one of these things are you going to reject? Which one are you going to keep as a statement, as a claim? Can somebody claim to get 20 births that are all girls? This is their chance. That's the probability of them getting it right, all 20 of them. That's pretty small. Here's a chance of getting 12 girls out of 20. So this one we reject because it's close to 0. And this one we keep. Not rejected. Because it could happen. All right, now when we think about probabilities, here's some words that we always use. An event is an event. That's the activity. Activity that produces data. Okay, we have two types. We have a simple event. A simple event is when the outcome or result cannot be broken down any further. Into more simple components. So that's a simple event. In other words, it is what it is. Whatever you get, that's it. You can't go any further with the data. You can't break it down any further. You can't do anything else. Whatever constitutes all those simple events is called a sample space. The procedure of all possible simple events. Okay, so you start off with the sample. That's your procedure. You'll get a whole bunch of information from it, the data, from each of these simple events. Either ask a question or have them fill out a survey or pick a number, whatever. And that's each of those things are called events. Whenever you collect data, that's called an event. Let's look at how we would record the data, possibilities. if one birth, one child, what are the possible outcomes here? Yeah. Then your outcome is either a boy or a girl. That's it. If you have 3 births, then what are your possible outcomes?
Either 2 boys, 1 girl,
Well, yeah,
3
so we have 3
boys.
births. So we have the first one, they could be all boys.
Mm-hmm.
They could be a boy, boy, girl,
Mm-hmm.
boy, girl,
Boy
boy,
and 2 girls.
girl, boy, 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 girl, girl,
Girl, girl, girl.
girl, boy, girl, 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 boy,
girl.
and then girl, girl, girl. Because remember, each of these outcomes are events. So in the first one, it could be a boy or a girl. The second one, so they're not the same. Order is specifically important because we have 3 separate births. What did the first one come out to be? What did the second one come out to be? What did the third one come out to be? All right, so that's how we're going to start looking at these things is we have to look at what are all possible outcomes. This becomes more complex when we deal with games of chance. Whether we roll 1 die or 2 dice. It changes dramatically. Let's look at an example. Do we have an example here? Oh, let's discuss probabilities. The probability of an event looks like this. This is how you write it down. This is read the probability of event X. Or we shorten that as probability of X. Because X is your event. Each event is usually capital letters. P represents probability. Whatever's inside the parentheses represents your event. Each probability has to be between those numbers. Why does it have to be between 0 and 1? It's got to be between 0 and 1 because the formula for the probability is this. On the top, it's the number of times X occurs in your all your data possible outcomes, divided by the total number of possible outcomes. So it's the same as percent, part over total. But we don't multiply these by 100. So which one is bigger? The number of possible outcomes for X or total number of outcomes possible?
Total number.
Yeah, the bottom number is always bigger. That's the total number. So what we can look at here is if it never occurs, if you don't get any X outcomes, what's your probability? If it happens no 0 times, what's your probability? 0. 0 over anything is 0. So this is impossible. It'll never happen at 0. Or if it happens all the time. If it happens all the time, that means it's all the possibilities. So if we have 10 over 10, that equals 1. So this is for certain. Now, anything else between there is a gradation of discussion of terminology. This is certain. Anything below there could be likely to 50-50 when you get to the middle, and then unlikely when you get closer to 0. So our outcomes can look like this. This is impossible. This is for certain. It's going to happen. In the middle, don't know. It's 50-50. On this side, it's likely. On this side, it's unlikely to occur. The further you go to the 0 or the further you go to the outside, the more probable it becomes. The further you go in the middle, the less probable it becomes. You can't really tell. Where's my next example? Oh, when we do probabilities, we talk about significant digits. This is the number of decimal points. We typically go to 3 significant digits. Usually 3. Three significant digits, sigdigs. All right, let's look at an example. Example 4. Boy, boy, boy. Boy, boy, girl. Boy, girl, boy. Boy, girl, girl. Girl, boy, boy. Girl, girl, boy. Girl, girl, girl. Girl, boy, girl. No, girl, boy, girl. All right, what's this going to ask us? Find the probability of getting 3 children all the same gender. Find the probability of getting 3 children the same gender. So we're looking for probability the same. Remember the formula? So how many of the possible outcomes are all the same gender? Yeah, we got this one and we have this one. So we have 2 out of how many total? Remember, each probability has to be between 0 and 1. So that's a good probability. So what does that say? Is it highly probable, improbable, somewhat probable?
Mm.
Well, you had a 1/4 chance, 25%. That's pretty good. I mean, it's not the greatest. It's less than 50%,
It's
but
unlikely.
it's somewhat likely. Yeah, because it's on the lower end.
Mhm.
Okay, example 5. Find the probability. What is the probability that you will earn a grade of A in your stats course? With what we're given, can we answer that? Not really, because what are the extenuating circumstances? Can you say you're gonna get an A? No, because it all depends on how much work you do, how much time you study for your test, you do all the homework. So only thing we could do here is each person would probably give their own percent chance because they know themselves. So what do y'all think for yourself? What's your probability of making an A in this course?
Likely. Certain.
That's not right. That's almost 0. 70, 80%. Because you guys know what you guys spend doing this stuff, not me. All I do is lecture. At midnight on the last day of the semester, it cuts off. Anything that's done, it gets calculated. Anything not done becomes a 0 and it's done. So the probability of this one, let's say, is 80%, 0.8. Or you say 0.9. It's actually higher than that because I give you so many chances. Because you can take the test 3 times and keep the best score. So if it's not closer to 90, 95%, that means you're not really trying. Example 6, ghosts. In a Pew Research survey, randomly selected adults were asked if they have seen or have been in the presence of a ghost.
Mhm.
366 said yes. 1,637 said no. Based on the results, find the probability that a randomly selected adult would say that they have seen or been in the presence of a ghost. So the probability of yes. So what do we got to do to calculate this?
Probability of Yes. Number of times.
Remember, okay, how many yeses are there?
366.
How many total numbers are there? Yeah, first thing you have to do is
The
add these.
one
2003.
2003.
Remember, we want it to be 3 decimal places. So you have to find out the denominator will be everybody's possibility. People who said yes, plus people who said no.
So what's the answer? 0.183?
Yeah. Actually, so next thing I want to discuss complementary events. Remember that the highest you can get in any probability is 1. The highest probability you can get is 1. That's 1.0, which becomes 100%. That's the highest you can get. So what makes up all possibilities? If this has to equal total of 100%, we have 2 types of things. So if we're looking at probability of X, the probability of is X, the probability is not X. Because these are the only 2 possibilities. They have to equal 100% or equal 1. So we represent is X as just the X. The complementary, this is the complementary one. If it's not what you're looking for, then we use the X bar. You see the confusion here?
Mhm.
It's not the mean. You can't take the probability of mean. So when we say X bar in this case, we're talking about the complementary, meaning the opposite of whatever's there. For example, if all of my data were possible 1, 2, 3, 4, 5, 6, if A was 2, 3, 6, what would not A be?
145.
Yes. Because the probability of the entire list has to be everything from A plus the probability of everything from not A. In other words, you have to include all of them in there. That has to be 100% of your data. So let's look at these extremes. So the first one, what's the probability that Thanksgiving will be on a Wednesday this year? Zero to one? You can't say what is 0 to 1. We're looking for one probability. Has to be one number. What'd you get? By law, Thanksgiving is always the fourth Thursday of November. It'll never fall on Wednesday. So that's why it's an impossibility. So the probability of a Wednesday is impossible. How about the probability of a Thursday? 100%, so equals 1. Again, knowing the data set helps. How many of y'all knew that about Thanksgiving? That it has to be on the fourth Thursday of November. And it's a law too. It's besides 4th of July, it was enacted by the president. Example 8. Okay, the Pew Research survey of 2002 randomly selected adults. 1782 of those said they use the internet. Find the probability that the person does not use the internet. So what's the first thing we have to do? Because this 1782 of those who, yes, they use the internet. How many do not? Yes. We take all of our respondents minus the ones that use the internet. So these are do not use the internet. So that is 220 divided by the total number. Which is the probability of 0.110. So again, the probability of something occurring plus the probability of it not occurring has to equal 100% or 1. One of those has to have all of them if you put them together. Okay, the last part are called odds. If you ever gamble, you will see the words odds. What are the odds of winning? Basically, it's saying, what are your chances of winning? And the definition, actual odds against an event occurring are the ratio of P of not happening divided by P happening. Usually expressed as A colon B. So it's, these are the odds for X to Y. In other words, if you saw this, you would read it as 3-to-1 odds. Reducing the largest common factors, express the odds as 4-to-1/16. So why is it actual odds against? Who is it against? It's against you winning. The odds in favor of you are written the same way, but it's just the opposite. It's just A to B or X to Y. The payoffs is a determinant of what happens. The net profit are to the amount you bet. So how much you can win to what you bet. So if you heard of 3-to-1, if you bet $1, you'll get paid 3. Which means you won how much? 2. Very good. Very good. A lot of people think I won $3. No, you bet $1. You're just getting that dollar back. So you actually won 2. So if you had 5-to-2. So if you bet $2, you get 5 back. You never ever want to be in this situation. This is like having Usain Bolt versus a bunch of kindergartners in a foot race for 10 miles. I mean, this is, you pay $3, and if you win, you only get $1. So automatically, you've lost $2. So and this happens on sure things. So don't ever fall for that. So we figure out, using these calculations, these are the odds against. So you can figure out what your probability is divided by what your probability of the whole thing. So here's example 9. We'll finish up here. Example 9. If you bet $5, this is your bet, on 13 in roulette. Roulette's that round wheel that has all those black and red numbers on it, and the green ones on top. This is actually what started the whole concept of probabilities back in Monte Carlo in France. Okay, so if you have your probability of winning is 1-to-38. Why is it 1-to-38? Because you have 36 numbers, and then you have 2 green ones on top. So it goes from 1-to-36, and there's 2. And in order for you to win, you have to be exactly on that one spot. So you can only win 1 out of these 38. That's your chance of winning. But the payoff odds for the casino are 35-to-1. That's the payoff for the casino. So find the actual odds against the outcome of 13. Actual odds against getting a 13. So remember, it's not getting a 13 over probably getting a 13. So what's your probability of not getting a 13? Remember, the probability of winning, of getting a 13 is 1 over 38. So what's your chance of not winning? Very good. It's 37 over 38.
Mhm.
Because
And
there
yes,
are 38 possibilities. To
okay.
win, there's only one of them. That means there has to be 37 to lose. That's that
Oh,
one.
okay. Okay.
So, and the probability of you winning is 1
It's
over
one.
38. So we take the top number, multiply by the flip of the bottom. So what we get is 37 to 1 odds. So for every $1 bet that you make, you'll get $37 back if you get it right. How much net profit would you make if you win by getting a $5 on a 13? So if you made a $5 bet, then 5 times 37 is 175. That's not bad. That's what gets people coming back. If the casino was not operating for profit and payoff odds were changed to match the actual odds against 13, how much
That's
would you win?
185, not 175, sir.
What's that?
5 times 37 is 185.
Oh, yeah. It's 35, yeah. Yes, 135. And question 3, if the casino was not operating for profit and the payoff odds were changed to match the actual odds against 13, which is this, how much would you win?
You just gone with it.
Well, actually, in this one, minus our $5 bet, so you actually won $180. And if it was actual odds like this, you would only get 175.
Sorry, why did you subtract 5 from 185?
Because that's how much you bet. You didn't win
Oh,
that, you just got it back. Now, if the payoff odds, here are the payoff odds. So 5 times 35, that's 175. So question C is how much it would, if the casino was playing not for profit, then the odds against would be this much. So give or take $5, which is what your bet was. That's gambling. Don't do it. It's a lot of fun. Okay. That's